Scruggs style, and I learned 3 chords.
Yeah.
Huh? No. For the assembly.
When's the assembly?
Yes. Now, you get. Huh? That's the wavelength, but turn it into meters. This answer is in so many hertz that it has a prefix. It's either kilo, megahertz, gigahertz, or terahertz. It's either kilohertz, megahertz, gigahertz, or terahertz. Not terahertz. She hits, yeah, that's right.
Can the same teacher keep graduation 2 years in a row?
No. There's a law against it.
Is there really?
Yeah.
You joke.
Why would you? There's so many good teachers. Give me units. Yeah, like 70 kids voted.
Really?
Yeah, total.
I voted for you.
Yeah, it was overwhelmingly me, but out of 70. That's right. So, is that times 10 to the 9? Yeah, I love that.
That says to the 8, Michael, don't lie to me.
Are you serious or are you joking?
Why would you want the same teacher twice? That's right. I'm not.
Our graduation is different.
Not everyone goes to graduation. There's like
It can be the better last one ever.
I'm not going to go to the
last graduation. Yeah, that's true.
some people have to go to graduation.
Nobody's given me the prefix here. Is it times 10 to the 9th? Is that kilo, mega, or giga? There you go. That's that dog'll hunt. That's it. 2.46 gigahertz. I had a French student that pronounced that gigahertz once. We never corrected him. Yes, yes. Has everybody divided the speed of light? Yeah, that's right. What units? That's right. Yeah, and then get rid of the 9th. Just gigahertz. Yeah, there you go. Yeah. Class. Before we move on to the next thing, let us wrap our minds around what this means. This means, that's right, at 2.5 gigahertz, which there are some computers that run about that fast. That means that light can travel during a clock cycle 12.2 centimeters, which means it can go 6.1 centimeters out and 6.1 back, correct? Now everybody indicate with your hands how big is the motherboard of a computer. Now show me how big the fatherboard is. I'm just kidding. Anyway, yes, there are no fatherboards. That's the sad thing, right? So the motherboard is this big. Is that bigger than 6.1 centimeters? Yes, it is. So this is why computers are approaching a threshold or a limit as it is that we cannot go past by clocking them faster. Okay? And that is, the faster we clock them, the less distance light can travel, and therefore information can travel in a clock cycle. And so therefore, things that are more than 6.1 centimeters at 2.5 gigahertz, right? Because it's got to go there and back. Things that are farther than that are irrelevant to the processor. Only things closer than that can it fetch in one clock cycle, right? That's why processors have things called cache, memory that's on the processor itself. Because long ago, and they all have it now, it used to be like Pentium 2s, you could get one with cache or without cache. It's just a type of memory, fast memory that's on the processor, right? So now when it's executing code, it puts that code next to the processor because of the speed of light. Huh? Put that in your smipe and poke in, huh?
How do we know that it's gigahertz?
Oh, times 10 to the 9th is giga. 6th is mega, 10 to the 12th is tera. Right, so hard drives are now terabyte.
Do we have to pick gigahertz?
You can say times 10 to the 9th is fine. Yeah.
Just remember to always do it by 10 to 9.
It is. Those are in your data packet.
Big number. Oh.
Yeah. Now, I know it's exciting, but it's not, so be quiet. Okay. So, So the next concept, and I think we're on concept 2 today, is that light travels the speed of light. When we say the speed of light, that's the speed it travels in a vacuum, and in all other substances it slows down by some factor. And the factor by which it slows down is called the index of refraction. The index of refraction is the factor by which it slows down. So if the index of refraction is 2, it goes half the speed. If the index of refraction is 3, it goes 1/3 the speed. If the index of refraction is 10, I don't know if there are any that high, it goes 1/10 the speed it goes in the vacuum. It is the amount by which the light slows down, or, by the way, on the other side of that, it's the amount by which, the factor by which the wavelength is shortened when it strikes the new medium. So the index of refraction, n, is the speed of light divided by the velocity in the medium. Yeah? And since the velocity in the medium is always less than the speed of light, this number is always bigger than 1, or equal to 1 if it's the vacuum you're talking about, right? So that's the speed in the medium, in water, or ice, or glass, or diamond, etc. This is always 3.00 times 10 to the 8th meters per second. And this is a pure number between 1 and, I think they've gotten some really large ones. Right? And here are some indices of refraction. Notice that air is essentially the same as a vacuum. Very few people do work careful enough to see the difference between air and a vacuum. Right? Water is 1.33. That's one worth memorizing, right? Quartz, glass, and crown glass. I don't even know what that means. But glass is not glass. It's just different mixtures of things, right? Lucite, which is plastic, is 1.51. A diamond is 2.42. It's one of the highest natural ones. Yeah. Yeah, I'm going to give you the indices of refraction. That's typically what you look up. Now I want to show you something that is immensely important, and I can show you with my $600 wave device. So which medium up there is the slowest? For diamond, it really slows down in a diamond. And which one is the fastest besides a vacuum? How does light travel through nothing? A vacuum is nothing. Yeah, so for a long time, before Einstein came up with special relativity, they surmised that there had to be some medium for light. There had to be some medium for light. It's just that we couldn't detect it. And they called the medium ether, as in like ethereal, as in hard to detect. And they did experiments to determine the speed that Earth moved through the ether. Yeah? Because we're orbiting at 19 miles a second, so it's reckoned through a vacuum, correct? So there must be some medium there. And they did these very accurate experiments which yielded that we were never moving with respect to the ether. It's kind of funny, isn't it? Yeah. So either the ether of the universe orbited the sun with the Earth, or it didn't exist. They came up with a third explanation. That was that massive objects dragged ether with them as a sort of a boundary layer. You know? Because they really couldn't let go of the ether. Okay, this is light traveling in glass. It's quite slow in glass or diamond, right? This is light traveling through a vacuum. Now, when the light goes in there, when the waves go in there, something's going to change when it hits that slower medium. Either the frequency or the wavelength is going to change. One will remain constant, one is going to change. You decide which one it is that's changing. Is it the wavelength or the frequency? The wavelength is changing, the frequency is constant. Convince yourself that all parts of this have the same frequency, don't they? Because imagine what would happen if the frequency changed, right? What